Welcome everyone. The question that is shown on the screen, it is from the CBSE 2026 physics question paper. The question is a particle of mass capital M at rest speeds up into two particles of mass m1 and m2 having the non-zero velocities. Calculate the ratio of the de Broglie wavelengths associated with the particles. The de Broglie wavelengths or the Broglie wavelengths, that is the lambda equal to basically h divided by p. Okay, if I say that is the mass capital M, and that capital M, whatever the reason we don't know, but it splits off into two masses. Let us say this is m1 and let us say this is m2. Now when it splits off, then capital M multiplied by 0. If this is the initial momentum before this division, and this is m1 multiplied by v1, that is the momentum of the particle of mass m1, we can say this is p1. Okay, m2 multiplied by v2, which is the momentum of the particle of mass m2. Okay, so according to the principle of conservation of momentum, here obviously linear momentum I am saying, that is capital M multiplied by 0 equal to, you can say, m1 v1 plus of m2 v2. Okay, or we can say this is 0, m1 v1 I can replace it by p1 plus of p2. So you can say here p1 equal to minus of p2. So obviously this minus sign is for the direction, and this equation represents that their magnitudes are equal. So we can say simply the p1 magnitude equal to p2, their magnitudes are equal. The wavelength is depends on the momentum. So if I say lambda 1 equal to h divided by p1, or h divided by m1 into v1, then lambda 2 gives you h divided by p2, h divided by m2 into v2. Now if you do the ratio of this, that is lambda 1 is to lambda 2, this gives you h divided by p1 is to h divided by p2. Since p1 equal to p2, we can say 1 by p1 is to 1 by p2 gives you 1 is to 1. Okay, so the ratio of the wavelengths for the two particles is simply 1 is to 1. Thank you all of you.